All right, this one is number 38, chapter 7. And in this case, we have block A connected to block B connected to block C by ropes. And the whole thing's going to accelerate because you notice that this side here is 3 kilograms, this is 2 kilograms, this is 1 kilogram. So there's more force of gravity on this side. It's going to pull the whole thing to the right. So the whole thing is going to accelerate to the right. And what we're going to try to do is find that acceleration. So we have 3 moving blocks, so we're going to have 3 different free body diagrams. So let's start here for block A. We have tension, we're going to call this T1. This is going to be T2 on this side, okay? We have T1, we have MA times G. Notice T1 is bigger than MA times G. Because the whole thing is accelerating that way, this has to be bigger than that. But that's all that's acting on block A. Let's do block B. On the other hand, it has much more going on. It has MBG. It has a normal force. It has T2 going this way. It has T1 going this way. And it has friction going this way. And the coefficient of friction is given to us as 0.30. So that's what block B is. Notice again, everything is still on the axes. And this is block C over here. And block C has MC times G, and then we have we have T2 going that way. All right. Now, we got to be really careful here because the whole thing is accelerating this way, so we have to have our positive going the same way. So in this case, we're going to have positive going up here, positive going to the right here, and positive going down here. And we have to keep those signs right or you're going to get in trouble. Okay, so what I'm going to do for block A, I'm going to do F net X, which is going to be positive, so it's going to be T1 minus MA times G. But the whole thing's accelerating, so we have to put this as MA times the acceleration is equal to T1 minus MA times G. I'm going to solve that for T1. I'm going to say T1 is equal to MA times its acceleration plus MA times G. All right? So now let's go to block C. Like, why am I doing it this way? Well, it makes sense. Block C is over here. I'm going to say, oh, F net X, remember X is going down in this case, is going to be MC times G minus T2. But this is going to be mass of block C times its acceleration is MCG minus T2. Or if I solve this, T2 for T2, I'm going to move that over there, and it's going to be equal to MCG minus MCA. Now I'm going to do block B. F net X. So block B, F net X, is going to be T2 minus T1 minus the friction force. And then I'm going to replace this with MB times A is equal to T2. Well, I know what T2 is. I got it right here. So this is going to be MCG minus MCA. Now I'm going to replace T1, but remember I have to distribute this negative, so this becomes minus MA times A minus MA times G. Then the friction force becomes mu sub K times the normal force. Well, in the case, the normal force is just MBG. And so my equation becomes that. Now I want the acceleration, but there's an acceleration term there, there, and there. So I have to move all those to this other side and then factor it out. So I have MBA plus MCA plus MA is equal to MCG minus MAG minus mu sub K MBG. All right. Now I'm going to pull the A out, factor it out, and I'm going to divide by all that. I'm going to get A is equal to MCG minus MAG minus mu sub K times MBG all over MB plus MC plus MA. And then this is the point where I analyze it to make sure that we did it right. Notice mcg, this is positive. This is gravity. The force of gravity on this block is pulling it down. But it's being opposed by this one because you happen to make this one go up. So it's trying to go the other way. That's why that's negative. And it's being opposed by the friction force as it tries to slide across the table. So the top makes total sense. The bottom, all three of them are accelerating, so this has to be the sum of all the masses. You sum all those up, and those are all positive, so that's good. I'm just going to plug in the numbers, so this becomes 3 times 9.8, and you could have factored out a g if you wanted. Minus 1 times 9.8, minus 0.3 times 2 times 9.8, all over 3 plus 1 plus 2. And you get this thing is going to accelerate to the right at 2.29 meters per second squared, or 2.3 with 2 sig figs. So this is the answer.